Ladies, we're still in section 4.2, studying optimization. A gardener wants to make a rectangular enclosure using a wall as one side and 120 meters of fencing for the other three sides. Find the maximum area of enclosure. I want you to try to answer A and B on your own first. So pause the screencast, see if you can't determine those things, then turn it back on and check it. It is very important that you try to do this portion on your own without just reading what I write down so you can think through the process. All right, so let's see how you did here. What area is being maximized or minimized? It says find the maximum area of enclosure. So that tells me that we are maximizing area. The enclosure is a rectangle, so area is length times width. What are the constraints? Do you need to draw a picture? So I drew a picture. It said he wants to make a rectangular enclosure using a wall as one side and then 120 meters of fencing for the other three sides. So my constraints, there are only 120 meters of fencing for three sides of the enclosure. So I chose to label the length X and the widths Y. You could have switched those, it does not matter. So X plus 2Y equals 120. I think that the easiest thing to do to solve would be to solve for X for this constraint equation. So X equals 120 minus 2Y. So we'll use the constraint equation to rewrite our max function in terms of one variable and then simplify it. Our max function is area equals length times width, and in this case my length and width are represented by X and Y. So Y times X, or X times Y, represents my area. So I can substitute, and that gives me that area is X times, in the place of, oh, sorry about that, I just made a mistake. Let me erase that and back up. In the place of X, I'll put 120 minus 2Y times Y. And then if we go ahead and simplify that and distribute, then my equation is area equals 120Y minus 2Y squared. From here, I'd like you to pause the screencast and try to finish this on your own, and then turn it back on once you've had time to finish and check your answers. All right, so let's see how you did here. The derivative of A is 120 minus 4Y, and we have a critical value at Y equals 30. So I'll place that on a number line to complete the first derivative test, just to confirm that it was a maximum, not a minimum. And the number line test with the first derivative does show that it's a maximum. So we have a maximum Y value at 30. And remember that the problem asks us to find the maximum area of enclosure. So maximum area takes me back to this equation. A equals 120 times 30 minus 2 times 30 squared. So our maximum area that we could enclose with three sides and 120 feet of fencing is 1,800 meters square.